Have you ever wondered how our massive sun came to be? Join us as we explore the incredible birth story of our star. The prevailing explanation is the solar nebula theory, detailing the sun's formation approximately 4.6 billion years ago from a colossal cloud of gas and dust. The story begins with a vast, slowly rotating cloud of interstellar gas and dust, primarily hydrogen and helium. This initial cloud, known as a solar nebula, contained heavier elements scattered by previous supernova explosions. The crucial step was the gravitational collapse, likely initiated by a shockwave from a nearby exploding star, a supernova. This external force compressed the cloud, making it gravitationally unstable and causing it to begin collapsing under its own immense weight. As the cloud rapidly collapsed, it began to undergo a significant shape transformation. Due to the conservation of angular momentum, the collapsing material began to spin faster. This increased speed caused the cloud to flatten into a rotating, pancake-like structure called a protoplanetary disk. Most of the collapsing material was pulled towards the center of the disk, accumulating into a hot, dense core, the protostar, essentially a baby star. The next stage involved the ignition of the engine that powers the sun, nuclear fusion. The core of the protostar became incredibly hot and dense, reaching a critical point where immense pressure forced hydrogen atoms to fuse into helium. This nuclear fusion process releases a tremendous amount of energy in the form of heat and light. With the ignition of fusion, the sun was officially born and settled into its long, stable life. The outward pressure generated by continuous nuclear fusion perfectly balanced the inward pull of gravity, creating a stable state called hydrostatic equilibrium. At this point, the sun began its main sequence stage, where it has remained for 4.6 billion years, steadily converting hydrogen to helium. While the sun was forming at the center, the rest of the solar system was also taking shape. The remaining gas and dust in the protoplanetary disk eventually clumped together through collisions and accretion to form the planets, moons, asteroids, and comets. Finally, a strong solar wind from the newly formed sun cleared out much of the leftover gas and dust, finalizing the structure of our solar system.